Alright, today we are going to be continuing with polygons, and we're going to be talking about regular polygons. Alright, and this is the last section of this unit, so it's in 7.4 in your books. Alright, so our objectives for this lesson are to recognize what regular polygons are, and to use a formula to find the measure of an exterior angle of an equiangular polygon. Alright, so what's important here is equiangular. Alright, so keep that in mind. Equiangular means that it has all the same angles. Alright, so what is a regular polygon? A regular polygon is a polygon that is both equilateral and equiangular. So for example, an equilateral triangle, 3 equal sides, 3 equal angles. A square is a equiangular quadrilateral, and that's got 4 equal sides, 4 equal interior angles. Now, a 3-sided polygon and a 4-sided polygon have specific names: equilateral triangle and a square. Beyond that, you're just going to call them regular pentagon, regular hexagon, regular dodecagon, and again, all equal sides, all equal angles. So that kind of breaks that down for you. Just remember that everything's equal, sides and angles. So now we have a special formula for equiangular polygons, and we learned last chapter that the sum of the measures of the exterior angle 1 per vertex of any polygons is 360. So since each of the angles of a regular polygon have the same measure, we can find the measure of any exterior angle by simply dividing 360 by the number of sides, which gives us this formula. Well, I should say this theorem. Theorem 58. The measure E for exterior angle of each exterior angle of an equiangular polygon of n number of sides is given by the formula E, again, it's a measure of each exterior angle, equals 360 divided by n, which is the number of the sides of whatever polygon you have. So, and that's really all there is to this particular section. So let's put it into practice, because you can use it a few different ways. So how many degrees are there in each exterior angle of regular nonagon? Now hopefully remember, a nonagon has 9 sides. So we start off with our formula, E equals 360 divided by n, and we replace n because we know the number of sides is 9, and then we can find out that each exterior angle is going to measure 40 degrees because it's got 9 sides. Each exterior angle has to equal 40 for it to equal 360 total for the sum. Easy enough, right? Alright, next one. If each exterior angle of a polygon is 18 degrees, how many sides does a polygon have? So now we have a different bit of information. We're going to start with the same formula. E equals 360 divided by n. But we don't know the number of sides, so that's going to remain our variable. But we do know the measure of each exterior angle, which is 18. So we have 18 equals 360 divided by n. And hopefully remember the algebra steps to do this, because essentially what you have to do to get rid of the n on this side, because we can't find it, the variable, if it's in the denominator. So we multiply both sides by n. These cancel out. This becomes 18n equals 360. And then to get n by itself, we divide by 18 on both sides to get n equals 20, which is the number of sides. Okay, so remember, you have to take the n and move it over to whatever the exterior angle is. Alright, now we know that if each angle of a regular polygon is 108 degrees, how many sides does it have? So, for these types of problems, because this doesn't say anything about an exterior angle, this is each angle, and when it says that, it means interior angle. So we have to find the measure of the exterior angle first, and you do that by subtracting the measure of the angle of a regular polygon from 180. Then substitute that answer into the formula. So we can take 180 minus 108, which is going to give us 72. and that's the measure of each exterior angle. Okay, then we can say, okay, we've got our formula E equals 360 divided by n. We're going to substitute E with 72. So we get 72 equals 360 divided by n, and convert that to 72n equals 360, and we come up with n equals 5 sides. Now they could kind of throw you for a loop here and say the sum of the interior angles of a whatever hexagon equals something, and then you have to kind of find out what each interior angle is, but you'll have enough information for that. That would be a more involved problem though, and if we come across that, I'll be sure to walk you through it. Alright, find the measure of each angle of a regular decagon. Now what do we do? Okay, it doesn't say anything about exterior angles, okay, but what we do know is that we have a decagon. And again, you're going to have problems like this, and it's not going to have a diagram. So you're going to have to know that a decagon has 10 sides. So we're going to use the formula E equals 360 divided by n. We're going to substitute 10 in for n, because n is the number of sides. So we get 360 divided by 10, and that's going to give us the measure of our exterior angles, which is 36. Okay, but since it's an exterior angle, okay, we need to subtract it from 180 to find the measure of the angles within the given polygon, or the interior angles. So we do 180 minus 36, which gives us 144 degrees. So each angle inside the decagon is 144 degrees. Hopefully you can see how that is. If not, make sure you make a little note in your notes to ask a question for more clarification on that. Alright, and finally, find the measure of each exterior angle of an equilateral quadrilateral. Now I want you to pause it here and try and do this one on your own and see what you come up with. So pause it, take a minute, it's not a hard problem, and then come back to me and you will find, hopefully you got this, that an equilateral quadrilateral is not necessarily equiangular. So we can't answer it without more information. For example, a rhombus is an equilateral quadrilateral, right? Shaped like this. Okay, but these angles are not all congruent. These opposite ones are, and these opposite ones are, but they're not all congruent to each other. So again, you need to pay attention to the wording. Please, please make sure that you are being very careful in how you read these problems, because that's probably going to be the biggest mistake that occurs. So, and that about wraps up this video. A nice short one to finish off the unit. This unit shouldn't be too terribly difficult, but make sure that you go over everything and be prepared for the review. Okay? And that is it. Oh, and watch out for the the questions on Edmodo that'll follow this. Again, your way of proving to me that you watched the video along with your notes that you'll show me in class. Okay?